Imagine you're at work and realize that you might not have turned off
Meron na
the air
po?
conditioner while leaving your house. Instead of
Yes,
traveling
ma'am,
all
meron
the
na
way
po.
back home,
Thank
what if
Yes,
you.
you
ma'am,
could
meron
use your
na po.
smartphone to know the status of your AC and perhaps even turn it off? Wouldn't that be amazing? Well, yes. And this can be achieved with the help of the Internet of Things. Until recently, access to the internet was limited via devices like the desktop, tablet, or smartphone. But now, with IoT, practically all appliances can be connected to the internet and monitored remotely. IoT is shaping the way we live our lives. It helps us get a better insight into the working of things around us. So, what exactly is the Internet of Things? IoT is a system of interrelated devices connected to the internet to transfer and receive data from one to the other. A smart home is the best example of IoT. Home appliances like the AC, doorbell, thermostats, smoke detectors, water heaters, and security alarms can be interconnected to share data with the user over a mobile application. The user can now get detailed insight into the working of the devices around him. Think about it. Until recently, the internet helped people connect and interact with each other. But now, inanimate objects or things have the ability to sense the surroundings, to interact and collaborate with one another. For example, in the morning when your alarm goes off, the IoT system can open the window blinds, turn on the coffee pot for you, and even turn on the water heater. Although all of this is fascinating, there's a lot that goes on in the background to ensure seamless functioning. From effective communication between devices to accurate processing of the data received, a lot of components are involved. In the context of IoT devices, hardware can be classified into general devices and sensing devices. The general devices are the main components of the data hub and information exchange. They are connected either by wired or wireless interfaces. Home appliances are a classic example of such devices. The sensing devices, on the other hand, include sensors and actuators. They measure the temperature, humidity, light intensity, and other parameters. These IoT devices are connected to the network with the help of gateways. These gateways, or processing nodes, process the information collected from the sensors and transfer it to the cloud. The cloud acts as both the storage and processing unit. Actions are performed on the collected data for further learning and inferences. Wired and wireless interfaces like Wi-Fi, Bluetooth, Zigbee, GSMs, and so on are used to provide connectivity. To ensure its ubiquity, applications need to support a diverse set of devices and communication protocols, from tiny sensors capable of sensing and reporting the desired factor, to powerful back-end servers that are utilized for data analysis and knowledge extraction. To help you understand its working, let's take a simple scenario. Let's suppose you want to water your garden every time the moisture level in the soil drops. Instead of doing it manually, you could automate it using IoT. The sensors and actuators installed gauge the soil for its moisture. This information is sent to the IoT gateway with the help of communication protocols like MQTT or HTTP. The gateway significantly aggregates data and feeds it to the cloud with the help of Wi-Fi LAN. Once the moisture level drops, the system is immediately triggered and the sprinklers are turned on. However, with the information stored in the cloud, a detailed analysis like the time of the day the sprinkler was turned on, the rate at which the moisture in the soil reduces, and so on, can be done, and the report could be sent over to you on your smartphone over an app. With the improved response, monitoring, and analytical capabilities, IoT is being adopted in almost all industries and domains, opening doors to endless applications. Today, IoT is being used extensively to lessen the burden on humans. To name a few, IoT is deployed for smart homes, wearables, watches and bracelets, smart cars, smart farming, smart retail, smart grids, smart city, and smart healthcare. With such a wide spectrum of applications, the future of IT looks more promising than ever before. In 2018, there were about 23 billion connected devices, which was more than double the world population. According to experts, there will be over 80 billion devices by 2025. IoT is a vision to connect all devices with the power of the internet, always learning and always growing. The integration of IoT with other technologies like cloud computing, machine learning, and artificial intelligence is paving the way for many new and exciting innovations. And that is the Internet of Things for you.
Okay po. So, Overview on web evolution. We have here 1.0, the shopping cart and static web. 2.0 is the writing and participating web. 3.0 is the semantic executing web. 4.0 is a mobile web, and 5.0 is open link and intelligent web or emotional web. So under the web 1.0, it is the first generation of web. It allows only read by information from web. It has only limited interaction between sites and web users. It is simply an information portal where users passively receive information without being given the opportunity to post reviews, comments, and feedback. It is an era of static website and representation of static content. The 2.0 is the social web. It is second generation of web where people have control over the data as read and write. It is facilitates interaction between web users and sites, so it allows users to interact more freely with each other. It encourages participation, collaboration, and information sharing. Content type is audio, blogging, calendar, CRM, e-learnings, email, forums, games, knowledgeable base, multimedia portals. Application are like yung example is the YouTube, Wiki, Flickr, and Facebook. On Web 2.0 is describe the current state of the web, which has more user-generated content and usability for end user compared to its earlier incarnation, Web 1.0. Web 2.0 does not refer to any specific technical upgrades to the internet. It refers to a shift in how the internet is used. In the new age of the internet, there is a higher level of information sharing and interconnectedness among participants. Under the Web 3.0, the semantic web, it is the third generation of web. It is open, intelligent, with semantic web technologies, distributed data source, natural language processing, machine learning, machine processing. Computers can interpret information like humans, intelligently generated, and distribute useful content tailored to the needs of user. It includes transforming the web into a database, a move towards making content accessible by multiple non-browser applications, the leveraging of artificial intelligence technologies. The technologies are RDF, XML, URI, API, AOUT, OWL. So makikita po natin dito sa image na to yung Web 3.0. We have here the crypto for game, for app, and from web. So yung mga dapat natin ngayon na experience natin ngayon. Actually, this is Web 4.0 is intelligent web. It is fourth generation of web. It is intelligent learning, self-learning, self-organizing content, all device in the real and virtual world in real time. And the last one is Web 5.0. It's a symbiotic web. It fifth generation of web, but this is also up to now dinidevelop pa siya. Yun yung pagkakaalam ko po. It is an emotionally connection web between humans and computers. Now web is emotional less and it does not perceive or feelings and emotion. But in 5.0, it identify our emotion and will respond to our emotions. So, a powerful, sabi nga po sa Clutrain Manifesto noong 1999, a powerful global conversation has begun. Through the internet, people are discovering and inventing new ways to share relevant knowledge with blinding speed. As a direct result, markets are getting smarter and getting smarter faster than most companies. So, the references po, and maraming salamat po.
Okay, so actually at present, no, especially when it comes to IoT, the future of IoT has the potential to be limitless. No, advances to the industrial internet will be accelerated through increased network agility, integrated artificial intelligence, and the capacity to deploy, no, automate, orchestrate, and secure diverse use cases at hyperscale. No, the potential is not just in enabling billions of devices simultaneously, but leveraging the huge volumes of actionable data, which can automate diverse business processes. So as networks and IoT platforms evolve to overcome these challenges, through increased capacity and artificial intelligence service providers will edge furthermore into IT and web scale markets, opening entire new streams of revenue. An exciting wave of the future IoT applications will emerge, no, brought to life through intuitive human-to-machine interactivity. So we have Human 4.0, will allow humans to interact in real time over great distances, both with each other and with machines, and have similar sensory experiences to those that they experience locally. This enable new opportunities within remote learning, surgery, and repair. So immersive mixed reality applications have the potential to overcome the next platform after mobile. Realized through 3D, audio, and haptic sensations, and becoming our main interface to the real world. So bringing future IoT to life will require close synergy between the IoT and network platforms. So this continue to be a key focus area of some research when it comes to IoT. Okay, so actually we have a IoT-based smart factory as what our presenter mentioned. No? We're in the factory automation with the latest cellular IoT technology improves efficiency and results. No, I don't know if you are familiar with the Ericsson Panda factory. No, continually explore ways to optimize manufacturing processes. The first tier provided a 50% return on investment, while break-even is projected to be reached in less than 2 years. We have also a healing hand, no? From specialist oncology to simple ailment diagnosis. A large percentage of the world's population cannot reach and afford the healthcare professional that they need to treat them. They have also tactile reaction, no? And so on. So actually, the IoT is a very promising one. No? So when it comes to an enterprise approach to IoT modeling and application, the diversity of IoT application and needs present both challenges and opportunities for enterprises. So in this series, we need to take the holistic, no? The holistic process-oriented approach to designing solutions and IoT modeling, considering top-down enterprise, centric needs, and bottom-up technology capabilities simultaneously. No? What does it mean to take an enterprise or process perspective towards IoT? No? So taking an enterprise process perspective means that we start with the challenges or needs of an end user. So this can be a person or an organization or a different in an enterprise or a role in an enterprise. And it articulates them in the end user's terms. Now, this is as opposed to starting bottom up from technology and an isolated problem with the associated risk of resulting in a stovepipe solution. So they modeled according to how the end user sees their reality. So for example, the person responsible for the production line in a factory is interested in efficiency, low cost, ensuring uptime of machines, the timely delivery of what is produced, and of course, maximizing the production given the resources and so on. So what are the benefits of an IoT enterprise? From an enterprise perspective, starting with modeling user needs and refining them further by digging deeper from the enterprise, IT and OT layers down to the machines and production lines. It means that the process begins with the needs of those not familiar with IoT as a technology. So by capturing a holistic picture of how the enterprise operates and what the needs are in formal way, it provides the baseline of realizing the IoT in IT solutions. Of course, in identifying high-level enterprise requirements and modeling a top-level business process flow in an end-to-end enterprise-centric application context, covering the enterprise and associated OT perspective, and doing it in the spirit of low-code programming. No? While the detailing sub-process to reach common resources and tasks as part of decomposing the top-level business process, hence linking the enterprise and IT perspective, and ideally reaching application independent and reusable resources and components. We need also to take a look in a mapping, no? Mapping the most granular sub-processes to functional components that can be represented by underlying microservices and IoT resources, the latter providing the link to OT. No? Orchestrating and executing both enterprises, no, process relevant events and IoT event and data streams in a consistent framework of reusable components. So in order for us to capture the full potential of IoT across different applied sectors, the means for effectively developing and integrating IoT application that consider the richer and wider needs of an enterprise are still missing, but baseline work exists that can be further exploited. So our approach builds on previous work, and we propose further work that can help close the gap between the enterprise process-centric and IoT-centric perspective that we believe will make IoT application more enterprise-friendly. I think you are familiar with business process modeling, no? That is identifying and defining patterns of processes inside an enterprise. Our focus, of course, is on processes that involve physical assets and machines and how they are engaged with IoT. And this will enable us to analyze and optimize operations and further lead to fully automated processes of asset-intensive enterprise operations such as manufacturing, buildings, utilities, agriculture, and process industries. Because the business process modeling and notation is a specific standard developed for business process modeling. It can produce formal process specifications that are executable, that can be mapped to microservices and IoT resources. Generally, the business modeling and notation provides enterprise with the capability of understanding and communicating their internal business procedures in a graphical notation that is based on extensible markup language or the XML. That's why a while ago, our presenter discussed the Web 1.0, 2, 3, 4, 5, and so on. It enables organizations to adjust to the new internal and business-to-business needs and circumstances quickly. So, the IoT operational and delivery model is via IoT application enablement platforms that provide horizontal tools for building applications. So to date, those platforms have primarily been about infrastructure services such as connectivity, protocol adoption, device management, and secure device onboarding. The more data-centric aspect of the platform are to a large extent is still rather simple and point application focused. So for instance, applying a specific artificial intelligence-based task such as predictive analytics to understand when and how a machine might fail, or using rule engines to achieve some level of programmability. But what remains is how IoT application can be made both richer in features and capabilities, as well as effectively integrated and enriched into the more complex overall enterprise business processes. Okay? So integrating IoT application into enterprise processes, no? IoT applications should not be looked at in isolation or isolated solutions to a very specific and confined problem. They should rather be viewed as part of an integrated into the overall processes of an enterprises. Because the business process modeling approach is a way to ensure this integration is effective across different departments of an organization and that the cross-enterprise processes can and should be fully automated. As a result, it would help break internal silos or as part of the digitalization journey. Okay, so therefore, we need to understand the framework for how to build, orchestrate, and execute solutions following our process-oriented approach. And we need to understand the IoT service providers and some research about future of the IoT or an Internet of Things. So I think that's it for this topic.